Oh, are we on? Anyone on? It looks like we are running. Is anyone on today? Hey Max, good to see you. Audio check, check. Video check, check. Voice, how's quality? Check, check. How's the sound? Video quality? We sound good? Okay, good. Excellent. Thanks for your help, Max. Yeah, also, thanks for all your support this year. Hey, Nick. Thanks for all your support this year as well. This is the second to last one. This is the second to last live Twitch stream. Yeah. Today I'm just gonna get loose today. I mean, most of this is, we're gonna have some fun. I'm drinking tea right now. Thanks for, want to thank you for a fantastic semester. Let me just say that your support really, really means a lot to me. Second to last class on Twitch. Second to last Twitch stream. So you may be wondering, we're gonna do this again in the spring semester, spring 2022. Yeah, you bet. I've said this every semester. Once you get invested in things like Twitch and online streaming, it's hard to stop. It's really hard to stop. Okay, so I'm going to begin. We're late 2 minutes over. Hello, everyone. I'm Ming Chow, Associate Teaching Professor at Tufts University. Yeah. Second to last Twitch stream of 2021. And I'll tell you a little bit about the last Twitch stream, which is next Thursday. So next Thursday, I'll just give you a clue. I'll give you a clue on what the last Twitch stream will be. Let me see how much I can get away with next Thursday. Again, let me see. I'm really wondering how much I can get away with on the last Twitch stream. But today, it's a topic that is definitely fun to talk about, and a real one. It's not one of the core topics of the course. It's not networking, network hacking networks, crypto. It's a good follow-up to malware. It's a very, very good follow-up to malware. And that is, assume that you have been hacked. Assume that you have received malware. Okay, now you got to play the role of Sherlock Holmes. You got to play the role of CSI. What happened? Who done it? How do you recover from this thing? And the big idea is forensics and incident handling. They're two different things. But one of my favorite activities that I want to do today, if you remember from the first lab, on the very first lab of this course, I asked you to, there was a question on the lab, which was on using Linux commands. And it was one of the last questions, the second to last question, which I can pull it up. You got it? Yeah, we do. This question. The question on the lab was, what command can you use to securely delete a file? Now, if your answer was RM, then, and that's it, no flag with RM, that was exactly what I did not want you to do. If you're just saying RM, to securely delete a file, that's totally incorrect. If you do a straight RM for remove command on Linux or Unix, while it deletes a file, it doesn't securely delete it. What that means is, you may be asking, wait a minute, does that mean that you can recover a file that was deleted by way of RM? Yes, that's exactly it. Wait a minute, can I recover a file that was put into the trash? Yes. Yes, you can. You can secure, yes, yes. Anytime you actually move a file to the trash or on Windows or Mac, it's no different than doing an RM on a system. And one of the things I want to exercise and I want to show today is how do you actually securely delete a file? Like, how do you, well, recover deleted files? Okay? But the first thing I wanted to come today is a couple of things. How do you acquire data from a disk? How do you analyze a disk using Autopsy, Sleuth Kit, and Foremost? These are forensics tools. They are included on Kali Linux. And of course, ultimately, it leads to how do we recover deleted files off of a disk. Okay, so here's a nice scenario for you. Is like, and again, this topic is nice enrichment. It's really good after a follow-up of malware. Well, imagine that you have been attacked, compromised, or involved in a criminal accident. Ooh, incident. Ooh, like what's the evidence? What happened? Who was involved? All the who, what, when, where, why. This is classic forensics. But what is forensics? Forensics boils down to 5 things. The preservation of computer media. That includes hard disk, phones, desktop, laptop, but even the router. Identification of computer media. Extraction of data, metadata, files, the list goes on. Interpretation of the evidence of everything that was found, and last, documentation. We're leaving no stone behind, and very likely you may even need to present your work in the court of law. The process is analyze, assess the situation, acquire data, analyze the data, and the report. I think the most laborious part by far and away is acquiring and assessing the situation. So let's say if you are actually, well, I've been involved in one of these before. Let's say before you actually are, you have a pretty strong suspicion that something is happening at a certain location, geographical location. Before you actually go and do anything, if you're in law enforcement, you actually have to obtain a search warrant. And here's actually a copy of how a search warrant actually looks like if you're in the Commonwealth of Massachusetts. This is a process where you have to fill out a form, which is like 2 pages, get assigned by you, get filled out by you, and also have to be sealed by court as well too. You gotta obtain a search warrant before you do any search, especially if it's a criminal investigation. More of what a search warrant actually looks like. It's 2 pages. Oh, here's actually an example of a search, the actual search warrant. Yeah. And as you can see, this is a form where there's a bunch of lines on here, and this is actually what you actually have to fill out if you actually find a whole bunch of things. I mean, you're at a crime scene, you're in an incident, and you're in a scene where you have to, I don't know, let's say you found a whole bunch of computer media on a disk, external hard drive, phone, USB, video game console, router, you name it. You gotta list it all down. You gotta list it all now on the search warrant. So it's a very exhaustive process. Very, very exhaustive. The search and the preservation of the media really, really, really it can be pretty laborious. Some terminology that you gotta know when you're dealing with forensics and incident handling. Volatile data. Now, you can collect data on, it's actually not just as simple as just just ripping out disk, making copies, entire copies of a hard disk. It's a lot more involved than that. The one I think that people are most familiar with is non-volatile data. That's the one that if you actually are doing if you're doing an investigation, you take the hard disk, the USB drive, all the hard disk in the world. Those are non-volatile data. Okay, especially when a machine is turned off, they're not going to change. Volatile data, yeah, that also becomes a part of an investigation. Volatile data is, think of trying to shoot a moving target. This is data that's going to change all the time. And is this important for investigation? And the answer is absolutely it is. Because now you can have passwords, URL, even like operating systems now stored in random access memory processes. Those are all volatile data. They're treated differently than non-volatile data. There are ways to actually get data off of RAM and off of random access memory, hopefully while the computer is running. Because if the computer is actually turned off and they plug it pulled, then all bets are off, and too bad, we can't get anything. There are two types of ways that you can acquire data off of acquire data. The most easy, the most, well, I guess the most simplest, quote unquote, also the most exhaustive is called physical acquisition. A bit by bit copy of an entire physical store. You just make a bit by bit copy of an entire hard disk. Now, there's a huge cost to physical acquisition. It just takes a long time. I mean, how big are hard disks these days? We're talking about gigabits and gigabits. Now we're in a terabyte territory. To make a bit by bit copy of an entire terabyte disk, or like 80 to a 500 gigabyte, it's going to take hours. Hours. You get a copy of the entire disk, but it takes forever to actually acquire to make a bit by bit copy of everything on disk. Okay? And now it's getting much harder because disks are much, much bigger. I mean, we're not talking about 80 gigabytes or 80 megabytes anymore. 512 megabytes USB sticks were great back in the days. They were kind of quick to do. No longer. Now, on the other hand, if you don't want a bit-by-bit copy and you want to speed up time, but you only want to make like copies of certain directories and file on a system, that's what you call logical acquisition. One example I can actually say about logical acquisition is, for an example would be the Android file system. I mean, you don't need to make a full copy of the entire SD card that powers your entire phone. You only need certain partitions or certain files and directories. You don't get all the data, but it's a lot quicker. Okay. Now, when you're trying to make a copy of an entire disk, one of the biggest problems is hopefully no data gets in. If data gets in while you're making a bit-by-bit copy of a drive, it's called what they call contamination. So there are special devices called write blockers that actually allow you to acquire information on a drive without any possibility of leakage or, most importantly, contamination. That means nothing gets in, nothing gets out. This especially will be cool, especially for any pieces of malware that sends data over the internet, or any like polymorphic viruses that change the shape and form all the time. Nothing gets in, nothing gets out. Write blockers aren't cheap. They're also big hardware. That's how a write blocker looks like. Little device. Yeah, here it is. That's something like that. Want to make a bit-by-bit copy of the disk? Yep, you have to feed your disk into the write blocker. Nothing gets in, nothing gets out. Read only. Because you don't want any contamination. And last but not least is chain of custody. Chain of custody is a terminology that is, quote-unquote, cradle to grave. Okay? It's the entire chronology, the chronological documentation process. Warrant, seizure, custody, control, transfer, analysis, check-in, check-out, if there are more than one investigator, and disposal of any evidence, but like when the case is done. Okay, so what could possibly go wrong if you don't use a write blocker to acquire the evidence? I actually did mention this already. It's called contamination. What are the pros and cons of physical and logical acquisition? Well, I just spoke about that. Physical is completely comprehensive, but it takes forever. Like if it's a serious investigation and you need like everything, you gotta go physical. Logical, it's gonna be incomplete at times. So, hey, forensics tools. In terms of what are the forensics tools that you use, you already know most of it. Here's the deal. There's a reason. The other reason why I gave you the first lab on the Linux command line is the forensics tools are the stuff that you already know. A lot of it, like strings, MD5, SHA-1, SHA-50, the hash functions. The commercial and open source tools like FTK, NCase is like the gold standard used by like law enforcement and justice departments all over the world. Salute, Kit, Autopsy, they're all based on the tools that you already know. But the three tools that we're going to look at today are DD, Salute Kit, and Autopsy. And foremost, we're going to look at three tools today to do forensics. Okay? Now, here's a demo. Oh, here we go. We have DD, Salute Kit, and Autopsy, and foremost. Okay, so what am I going to do? Okay. So I have my terminal open. Oh shoot, you know what I need? Part of demo. Aha! One of the things I actually need is a disk. So let's say I have a USB stick here, which I have. See that? I have a USB stick. Hey, Believer, how are ya? USB stick. How do I make a bit-by-bit copy of everything on this USB stick? This is a 64 gigabyte, 64 gigs USB 3.0 stick. How do I make a bit-by-bit copy of this? I want a bit-by-bit copy of this entire USB stick. The tool that you would need to use is called, well, you need on Mac land, you need a combination. So, wait a minute. First of all, how do you actually know what disk to copy? On Mac OS land, all you need to do is something called sudo disk-util. Disk-util. What the hell is disk-util? Disk-util is disk utilities. Modify, verify, and repair local disk. Why do I need to use disk-util though on Mac OS? On Mac OS only. The reason is you need to actually, before you actually make a copy of the disk, you need to know which disk you want to copy stuff off of. So you want to do sudo disk-util list. And here it is. Here it is, I have disk-util will list two disks. /dev disk 0 and /dev disk 3. I'm not making a disk copy, bit-by-bit copy of disk 3. You gotta get this information right, because if you actually make a copy of the wrong disk, or if you're writing to that, everything bad happens. Now, I did not put in this USB stick yet. Watch what happened when I put in this USB stick. Shit. This is a problem. Okay. So, I just realized... Oh, no, that's not true. Not true. I was looking for a USB outlet. Aha, there it is. Hopefully this works. And it is. So as you know, I just popped in a USB stick. So the next step is, okay, I just want to make a bit-by-bit copy of my USB stick that I just popped in. It's a personal disk. And you notice now this util list will actually show 3 disks. And here it is, the 64 megabytes. So now I want to make a bit-by-bit copy of /dev/disk4. How do I do it? And I want to make a full bit-by-bit copy, 61.5 gigabit copy of /dev/disk4. I'm going to make a copy of this. Monica, this note right here. This is the disk I'm trying to copy. We're not going to do it, but I'll show you the command to do it. So, the tool to make a bit-by-bit copy of a disk is a tool that is built into any Mac OS and any Linux system. It's called DD. Does anyone actually on the audience actually want to take a wild guess what DD stands for? Be careful. Yeah, on Linux land it will be something like /mnt. On Linux, it's /mnt/disk4. Mac uses /dev. The question is, going back, does anyone know what DD stands for? Trick question. Really trick question. Anyone? Are you ready? DD stands for convert and copy. What? Yeah. DD stands for convert and copy, not this duplicate. Convert and copy, CC. You may be actually, what the hell? Really? Man, DD. Convert and copy a file. Here's the description how DD works, how you use DD. DD utility copies a standard input to standard output. Input data reads and writes in 512 byte blocks. If the input reads are short, inputs of multiple reads, yada yada yada. Okay. So what do you mean? Whoa, why is DD stands for convert and copy? Why can't it be CC? Okay. Does anyone? Okay. Sure. Back in the days when the Unix commands were built, people didn't type as we do today. How people type were like fingers, 2 fingers. So now you actually understand why so many Linux commands are two letters long. MV, LS, CD, DF, DU, and CC. CC is already taken. The C compiler. So they VI. So, you know, convert and copy, CC is already taken. Too bad. So what's the next option? DD. So this is how you actually make a bit-by-bit copy of an entire disk using DD. Sudo DD equals IF equals input file, output file equals something. And then, okay, the input file is /dev/disk4. The out file is, you can name it whatever, evidence.dd. And this is going to take a while, at least an hour to do. Okay, that's it. If you hit, that's all you need to do. Type enter, okay, thank bye. That's it. And then you just wait. It takes forever to do. Now, if you want to speed things up and instead of copying the standard 512 byte block, you do BS byte sector equals, let's say, you want to copy 5 megabytes at a time. Now, the higher this number is, the higher the BS number is, the chances of you getting disk corruption and not making a full and having mistakes happen is pretty high. Can I use this safely to make an image? Oh yeah, oh wow, it's good that Oblivion you says it. This is exactly what we do all the time, especially when it comes to Raspberry Pis. This is exactly what we, the question is great. Can I use this to safely make an image disk and restore? This is exactly what we do for Raspberry Pis. In fact, to manually create a disk for the Raspberry Pi, you use DD. And then you hit enter. But I'm not going to do this. I'm going to eject this. So if you want to make a disk for the Raspberry Pi, you use DD. And then you hit enter. Now here's the thing when you hit enter. It's no prompt, no feedback, nothing. Hold on. To Oblivion, I got you a gift. Raspberry Pi DD. Raspberry Pi documentation. Again, if you don't know what a Raspberry Pi is, it's just a $35 computer. The size of a credit card. Like this. Has all your hardware peripherals, but your disk is a micro SD card. But to make a copy of the micro SD card, there it is. There it is. So here's an example of how you actually use DD for Raspberry Pi. Whether you want to create a brand new disk from scratch, or if you just want to make a copy of an image disk, like your SD card, and then use that image to, things should happen, you restore it later. Great question, Oblivion. Great question. Now, okay, so you may be wondering, okay, we just did DD. So we don't have a disk to work with, though, because I just took out the USB stick. Don't worry, I have one. Wget HTTPS www.cs.tufts.edu/comp/116/evidence.dmg. Oh, shit. Time out. I think it is evidence. Oh, I'm an idiot. Sorry, I can't do. I'm an idiot. I'm gonna make a copy of it. I don't think I made it public. Yeah, oh, it's evident with a capital. Duh. The little things do matter. Yeah. Here it is. Duh. That is the address that we're going to use. Idiot. Silly me, it's 48 megabytes. Now, hold on, before we do anything, they're the same, right? Okay, well, actually, this is a good mistake that I made. So that's the disk that you want to make. What's the first thing that you want to do? The first thing that you want to do once you download a disk. Most important thing, if you're working with any disk, give you a hint. SSL. Calculate the checksum. Calculate the hash of the image file, of the disk image. You'll need this information because you want to make sure that, well, you did the proper download. You downloaded the right evidence file. And number two, if there's any weird things with the hash, something got corrupted. Yeah, you gotta verify. SHA-256. Okay, so that is it. What's the, sorry, are they the same? Yeah, the same hash. Good. Okay, I don't need this one anymore. I don't need this crap. Okay, now we can do whatever we want. Like, we can start our investigation now. Now, what is this disk? On Mac OS land, if you're on Mac, you should be able to double click on this, and a disk will pop up. But if you open it up, there's only two files that you see here, 2 items. Not bad. Now, wait a minute. Wait. Can I actually take a look at the evidence drive on a command line? It's like, sure you can. CD vol, the volume, so CD evidence. You can see it's only 2 files here. And minus LA. How many files do you see here? How many files are listed here, including all the hidden files? This is important. How many files do you see? It's only one. Give me a number. You should only see 2 files listed. But here's the quick trick question, though. Were there any files that were deleted on this disk? Are you sure there's only 2 files on this disk? There are more than 2 files. Now, what we're going to do is this. We're going to run this disk through the gamut, and we're going to uncover even all the files, including the deleted ones. I'm going to leave this open. I'm going to leave this window open. And we're now going to recover all the files. We're going to actually really uncover what's on this disk, including anything that got deleted with RM. This is where I'm going to pull up Kali Linux. I'm going to use VMware TextView. Keep that in mind, it's only 2. Now, the first thing I want to do on this Kali machine, I don't have access to the host, re-download that image. Same hash value that we calculated on the Mac LAN? Yep. Same one. By 933 EDA, yep. Okay. We got a disk now. The next thing we're going to do, we're going to do 2 options here. We're going to do 2 things. One, we're going to analyze this disk image that we just have, this evidence.dmg, using SleuthKit and Autopsy. So what are SleuthKit and Autopsy? One of the best looking logos in any software tool. SleuthKit and Autopsy is a suite for computer forensics, free and open source. Open source digital forensics, sleuthkit.org. Now, the Kali Linux actually have an older version, will have an older version of SleuthKit and Autopsy. SleuthKit and Autopsy, what Autopsy is just a front end. SleuthKit is a collection of command line tools and a C library that allow you to analyze disk images and recover files from them. It is used behind the scenes in Autopsy and in many other open source and command line tools. Autopsy, again, is free and open source. Okay? Now, how do you actually use this on Kali Linux, the latest version of Kali Linux? First of all, fire up Autopsy. Here it is. Leave it running. It says, here's your evidence locker, here's the start time, the remote host. Open a web browser. Yeah, sure. Beep. Firefox opens up. Warning, your Java browser has a JavaScript enabled. You do not need JavaScript and it is recommended. Okay, sure. Here it is. Here's Autopsy, an oldest little older version, front end. Now we're going to create a new case. Case number CS116, fall 2021. Description, evidence.dmg at Oblivioner. Yeah, the investigator for this case. We have a brand new case. There it is. Add a host. Host 1. Time zone. Fill whatever you want, really. Add host. Now we're going to add the image. This is important. Where is our image file? It's home / my username, evidence.dmg. Add image file / home / defcon / evidence.dmg. This is a disk. We're going to do a symlink, also known as an alias. Hit next. Well, here it is. We can actually create the hash. I'm going to ignore the hash value. Nice partition. Yeah, sure. I think it's a FAT16. Think. I hit add. Here goes nothing. Hit OK. Ooh, here it is. Okay, so now we can do an analysis, select a volume to analyze or add a new image. Okay, sure, let's do details of the disk. Oh, crap, well, it looks like there's nothing much I can do here. I can do this, but I don't need this. What about this one? This C. Detail. Oh, that's going to analyze. That's going to analyze disk. Oh, that's it. Keyword search. We can actually have credit card number, social security number, date. What if we analyze the C disk, though? Well, analysis. Oh. Hello. Here it is. Invalid characters. Oh. Holy shit. Hello, hello. What do you think the red color is? Anyone want to take a guess? Ah, here it is. Remember these things? We had a WebP. You can click on it. Oh, there it is. Oh. Hey, wait a minute. Wait. What's in this disk? We have a text file and then we have a picture. And I said, and you said there's only 2 files on this disk that you saw. Bikini Bottom Twitter on Reddit is like the best Twitter. Then wait a minute, now this is pretty dope. You're seeing images and stuff that you can't even see. Holy shit. You're seeing a lot more than just 2 files now on the evidence that we just downloaded on the Mac. Yeah, the red is all the removed file. Red is on Autopsy. Red means removed file. You can even do keyword search. JPEG, I don't think this is going to work. You're going to do keyword search like social security numbers, IP. Oh, hello. Holy shit. You can even find Wow, even IP, okay, that works. You can do keyword searches. This is way cool. You can do social security number, date, and all that stuff. File types. Sort by file type. Oh, 59 files on that disk. 12 images. Pretty nice. So one way to recover files from a disk, yeah, one of the ways that you can recover files on a disk is use full-blown investigation. Let's do that again. What's the crypto category? Yeah, let's do that again. It is pretty dope. Where? What is crypto category? I don't know. I don't know what crypto is. Oh, maybe keys. Maybe keys. Like, I think. So when files are removed, that means that the memory previously allocated for that file is just deallocated, but it still exists. You got it. You got it. Basically, think of it this way. It's like a flag. It's like a flag, like a Boolean variable. Like, yeah, it got deleted. But if you actually want to think of more technical detail, just think as the pointer is completely gone. And yes, unless it gets overwritten by something, then you can, but you can still recover it unless it gets overwritten for something. So just securely removing it by just like null out everything, or what they call zero out everything. Yes, you got it. You got it. So securely removing something might just null out everything. Yep, or zero out everything. Or just write it with all kind of random crap. Wait a minute. Wait. You just remind me of something. I told you I didn't prepare for this Twitch stream, but didn't need to. You remind me of something. I'm going to close this out. I'm going to get to my next tool next. But do me a favor. Remind me on how you actually secure wipe a disk. I don't need this anymore. Let's not do it. We don't need to do, well, we're done. Now, what I'm going to do, okay, hold your thought. Because I want apathetic thoughts. One of the things I actually need to show you is how do you actually secure, delete an entire disk. Secure, wipe an entire disk. Let's say you want to sell your computer one day. Then you stored so much stuff on there. What do? I'll get to that in a few seconds. But I want to show you foremost. Now, foremost, Mr. Craftmaster, magnet works, but seriously, the better option is use a barbecue grill. Burn the thing. Magnets are okay, but you can use some like 10 grand microscope. You may be able to recover some stuff. Dude, if you're gonna want to actually destroy a disk, you gotta put it in a barbecue grill. Burn the thing. It's the only way you can kill a disk securely. This goes back, this presentation I did 12 years ago, to the High Tech Crimes Investigation Association, the New England chapter. By the way, I used to be a member of the High Tech Crimes Investigation Association at the New England chapter. I was a young buck. You actually had to be vetted by police in order to join this organization. And I want to say that I haven't been a member for a long time, at least 10 years. But the HTCIA were one of the few people and few groups that were really, really nice to me. And they helped propel my career. Early on in my career, it was awesome to join the High Tech Crimes Investigation Association. I even wrote newsletters to them. I gave presentations. And I had so much fun. I haven't been a member for a long time. And at this time of the year, they would throw kick-ass holiday parties in Boston. And I haven't forgotten that. So I want to take this time and opportunity to say I haven't forgotten about the High Tech Crimes Investigation Association, especially the New England chapter. Only fond memories. I haven't forgotten about them, and I want to say thank you. The HTCIA. You got to be vetted out for, here it is. The HTCIA is a nonprofit organization committed to high technology training and education networking, largely for law enforcement. So much fun. You have to fill out an application, a lot of member benefits. A lot of cybersecurity professionals actually have a relationship with the HTCIA. They have an annual training. Who's the president now? I don't even know. If there's one thing I've certainly learned in my career, good people, good groups, they help you out. They set you very far. The Massachusetts, the New England chapter is awesome. I don't know anyone here. Been a long time. Well, why I bring this up is because back in 2009 I gave a presentation on a tool called Backtrack, which is, well, now known as Kali Linux. A lot hasn't changed since 2009. But this is one of my favorite presentations I gave because, again, like a lot of things, the presentation I gave stood the test of time. And one of the problem, I just want to show you a couple of tools on here and before I get to Foremost, which is one of my absolute favorite tools. One of the problems with DD is there's no verbose mode. You just press the enter key and then you just hope and pray that you get a confirmation message eventually, maybe like the next morning when you wake up. The Defense Cyber Forensics Lab, the DoD DC-3, actually built this code called DCFLD, which basically does not only had a status bar, but also had hash on the fly. Is that on it? DCFLD? Yeah, it's on here. Yeah, it's on Kali Linux too. Holy shit, this is cool. DCFLD was initially developed at the Department of Defense Computer Forensics Lab. This tool is based on a DD program with the following additional features: hashing on the fly, status output, flexible disk wipe, input, image wipe, verify, multiple input, split output. Oh my god. Okay. Without DD rescue, DD actually will kind of go kaput when it actually have a damaged disk sector. But this is my favorite tool, one of my absolute favorite tools called Foremost. Foremost is an image carver. So what you do is, it's a command line tool, but it's not full blown like a NCASE or an autopsy or a salute kit. And all you need to do is a command line. If you just want to rip out all the images from the disk, well, you just do Foremost minus S, I skipped 100 blocks, minus T for the type, minus I, image DD. It's just awesome to rip out stuff. So let's do it out on Kali Linux. JPEG, minus I. That's it. Boom. That was quick. Want to rip out all the images? Okay, let's see what we did. See the output? Oh. Almost ripped out 5 images. 1, 2, 3, 4, 5. Remember, this little thing on the Mac, we only had 2. Oh, whoa, there's no JPEGs on here. There are no JPEGs though when we actually saw this. Let's say the JPEGs that got extracted. There you go. That were on evidence.dmg. Wait a minute. I want to say instead of JPEG, can we do text files too? How about PNG file? It's not. There is one. There you go. What about WebP? Guess it doesn't support it. Oh well, but we actually did recovered quite a bit of files. WebP is kind of a modern file. That's that. Yeah. Wait a minute. I did get JPEG. I got some JPEG files too. I got one. I got one JPEG file. I did. I got one JPEG file too. A PNG. No, I got PNGs. I got them as you did. There should be one. That. There should be a bunch of JPEGs though. I'm pretty sure you may have gotten the same results I got. All right, so we did it. We did DD, salute kit, autopsy, and foremost. We've done the demo. All right. Yeah, I only got one too. So, what the hell is this thing called incident handling? General incident handling and forensics are two different things, but they're tightly intertwined. Incident handling is a really big term, also known as IH. Incident handling is really the logistics, communication, coordination, and function needed to resolve an incident in a calm and effective, efficient manner. Like don't bark up the wrong tree. That's it. Why is incident handling involved? Yeah, you don't want to bark up the wrong tree, dead-end investigation, legal issues, cost overrun, and organization. So what's the difference between incident handling and forensics? There are overlap. But think of it this way. Incident handling is like the big glacier, but forensics is only like a small portion of incident handling. Forensics is pretty straightforward. It's really the who, what, when, where, why. Straightforward. Is finding the and documenting like what happened, who done it. Who, what, when, where, why. Incident handling is anything. In forensics, is much with it, your scope of knowledge can be pretty narrower. Like you only need to know like things like in-case forensics, and that stuff. Incident handling, you need to know a lot more, including things like maybe programming, system administration, Forensics is much more narrower. Incident handling, a lot more broader. Now, the incident handling phases is PICERL. Preparation, identification, containment, eradication, recovery, lessons learned. In forensics, yeah, there may be lessons learned, but it's like, and probably there's maybe no recovery, especially if you're dealing with something in the court of law. But what I do want to mention is, if you want to take a good cybersecurity course, take the SANS Institute, SEC 504, Hacker Tool Techniques, Exploits, and Incident Handling course. I'm an alum of this course. I'm an alum. The SANS Institute provide a lot of kick-ass cybersecurity boot camp trainings. They've been around for years. This is where places like the Department of Defense send their people to. The instructors of the SANS Institute are world class. Also, I want to give a shout out and rest in peace to Alan Peller, who was one of the founders, who was the founder of SANS. He died recently. SANS trainings are not cheap. But if you're a student or you're an academic, you can actually get a really, really generous discount. These courses are boot camp courses, 1 week, 9 to 5 p.m. In person is 9 to 5 p.m. 1 week, Monday, Tuesday, Wednesday, Thursday, and then Friday is a half-day capture the flag game. And here it is. And there's a certification that goes along with the course called Certified Incident Handler. I got the certification many years ago, but I let it lapse after it expired in 2011. The left skills to conduct incident handling responses. Yada yada yada. We'll examine the latest threats, organizations, even cloud now. 50% of the class time is spent on hands-on exercises, using visual association tool to break down complex topics. What will you learn? Day 1. Oh, you even do a live investigation. Day 2. Recon, scanning, enumeration. Did we do that in this course? MITRE attack framework. Wow, they changed this course. Open source intelligence. Website reconnaissance. Network and host scanning with Nmap. It looks familiar. Accelerating scans with mass scan. Password and access attacks on day 3. Password guessing attack with Hydra. Password. John the Ripper. Hashcat. It looks familiar. Public facing and drive-by attacks. You got Metasploit, drive-by, command injection, cross-site scripting, SQL injection. It looks familiar, huh? Evasion and post-exploitation. I don't think I did anything on this one. Covering your tracks. Real-time intelligence. Capture the flag game. You need a laptop. Aw, Apple system and M1 processor cannot do this. Aw, it's okay. How much is it? Register now. Almost $8,000. Oh my God. This is a on-demand. This is an online training course. Damn. But you can get a nice job. I mean, I paid like $1,300 when I took it back in 2007. But then again, the rates have gone up for everything these days. But yeah, if you know, you can thank the SANS Institute. I mean, I took that boot camp in 2007, and a lot of the security course, a lot of stuff I've learned based out of that. Yep, boot camp was fun back in the days. Yeah, I was a young buck back then. For a deeper dive, takes the SANS SEC 504 course, and there's a bunch of white papers. Just want to bring you, very important, this is for Oblivion. Oh, it's a good thing I actually had this on the slide. You want to actually do a full disk wipe. If you want to do a full disk wipe of a hard disk, you need to use something called a standard called DOD 5220.22-M. It is a Department of Defense standard for disk wiping. Fucking long manual. Oh my God, I'm not going to read it. Alright, let me just give you the skinny. Boot and nuke. Oh, D-band. DOD 5220. Everything that you need to know about disk wiping. I think it's 3 passes. Here is how you actually, if you need to kill a disk or wipe out a disk, a hard disk for like before you sell a computer for someone else. Here it is. Yeah, it takes a lot of time, but it's secure as well. Now, if you do any dirty, sinful business on a hard disk, this is what you want. It's 3 passes, procedures designed to prevent data from being recovered by commercially available processes. Like, well, not commercial, it can be open source, we just did that. DOD 5220.22-M is the standard for best wiping method of your organization, but what is it? Here it is. 3 passes, the original requirements. 3-pass method is: pass number 1, overwrite all addressable location with binary zeros. Zero out all the space on a disk. Pass number 2, overwrite everything with 1s. Then do one last final pass with random bit patterns. Yeah, at least 3. At least 3 is recommended. Mac OS land back in the days was like, I used 7. Took double the time, but it was secure. By the way, you don't do this on a modern what do they call those things? What are these hard disk called? They're not the disk ones anymore. Oh my god. One of these solid state drive, SSDs. There you go. SSDs, solid state drive. Don't do this on a solid state drive because you'll kill the solid state drive. Because the more writes that you do, bad. Yeah, don't do it. So to really protect yourself, and if you really need to kill out a disk, wipe out a disk, wipe it out with 3 passes. DOD 5220.22-M. Pass number 1, binary 0. Second pass, binary 1, random pattern. They do this in the workplace all the time when like employees leave and stuff. Okay, but really, as Mr. Kraft said, actually for Mr. Kraft, put your disk into a barbecue or a fire pit. That's the best way to counter against forensics. Why is 3-pass necessary? That's a good question. Max, that's a very good question. You see, some people just argue, like Bruce Schneier said, you really only need just 1. But the only thing is, if you have a second or third pass, I just, quote unquote, just increase the chance of, decrease the chance of anything actually getting put under the microscope. Like if you use like a really high-end microscope, you may be able to recover stuff, but it's unlikely. So in other words, Max, 1 pass is pretty much what you call good enough. 3 pass is just like really safe. Great question. Usually these days I only do 1 pass of 0. Back in the days when it was like a 60 or 80 gigabyte, 7 pass. But it's a great question. I mean, people just argue, you don't need just 1 pass. I mean, just 1 pass is good enough, but yeah, that's it. That's all I got. I hope you had fun. Last time I did a normal window, I couldn't recover anything. Yeah, I mean, yeah. Not quick. 1 pass is usually called you got good enough. 90% job. If you want to get a 95 to 100%, 99%, just 2 or 3. All right, folks. Wow. We actually spent a full hour. Hey, folks, it's been a lot of fun. One last Twitch stream next Thursday. And let's see how much we can get away with next Thursday. Enjoyed it. I hope you enjoyed it too. Take care, everyone. Happy December. See you next week.